In this video I'm going to have a look at the code behind the maze game for GameFrame. So first of all, just having a look at the game, just a quick review. We've got a few objects on the screen. We've got a teddy bear, who's the player, and we've got these bricks that stop you going through them if you're the player. We've got the enemy here, this ghost, and if he gets in contact with the teddy you lose a life. And we've got the end goal. Once you reach it, then you finish the game. We've also got some text down the bottom here that displays the current number of lives. And we also have two different types of blocks: the solid blocks that you can't go through, and the hidden doors. Now the way the teddy goes behind is we've also got layers or depth, so we can set the depth of the hidden door to be higher than the teddy. So the teddy's behind it, but the teddy's above the background. So that's the way we can get the layering. And there's no blocking code there, only blocking code for the other bricks. So if I go through and I collide with the enemy, you can see I get put back to the start and my lives drop. So my lives are down to 2 now. I collide with him again and I'm onto my last life. So I'll get past him, and then once we're up here, I'll just show you there's another hidden door here as well. They're the only two. And when I get to the end and collide with the flag, that ends the game. So with GameFrame, you can of course have multiple levels. You can navigate. Once you beat the level, you go on to the next level, but if you fail, you go back to the start. You can put scoreboards in, but that's manual at the moment. That's something I'm going to be working on in later versions of GameFrame, where you can just simply say show leaderboard, add somebody to leaderboard, and it'll just be a single line call. But for the moment that's a bit manual, so I'm just displaying a single room. So let's have a look at our structure here. So this is GameFrame, and the way you set it up is you download this framework, and all the code that makes it happen lives in here, and this will grow over time, but it's got all the fundamental code in there at the moment. And then it's completely event driven. So what we do is we define our objects that are in the game and how they react with other objects, and then we just let the thing run. So let's having a quick look how difficult it is to add an object in the game. So let's have a look at one of those blocks first. So this part here, this is going to be common to all objects. It's basically saying that we're going to call this thing a block, and it's going to be a room object. So it's going to be something that exists in game framework. And we're going to say it takes some parameters when you create it, which is going to be the room it's in and its X and Y coordinate. And we've just got to pass that back up to the room object as well that it inherits from. Don't have to worry too much about that. That's going to be the same for every object. So as long as you substitute in the relevant parts, then it's easy. So we set the image of it, so what we're actually going to see on the screen, and we're adding this PNG. We set the width and the height and the bounding rect, which is what we use for collision detection. And that's it. The block itself doesn't have to have any intelligence at all. It's just when you create one of these, you give it a position on the screen and the image that's going to be shown. So it's as simple as that. If we look at the door version of the block, well, as you'd imagine, it's the same thing. However, we've set the depth so that it's higher than the player. So when the player and the block are in the same location, then you'll only see the block, you won't see the player. Again, we're not handling any collision or anything. With this particular one, we wouldn't do any collision. That's all going to be handled by the player. So it's just defining the block exists and putting it somewhere. The goal, exactly the same thing. So this is all very, 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 very simple code at this point. We're just defining an image and putting it in a location. The monster does a little bit more. So we've set the speed to be -6. So that's going to start traveling to the left initially. And we're also going to register for a collision. So what we're going to say here is if the monster runs into a block, then we want to handle that. So the reason why we have this line here is basically for efficiency of the framework. So I'm not checking every object against every other object. It's only going to check collisions with a block. And then we've got these built-in functions that you just have to override. So handle collision we just implement that, and then we'll be able to handle it. So self is obviously this monster object, and other is what it's colliding with. Now you can register to handle multiple collisions, all different objects, so that's why we figure out what the name is, and if it's the thing that we're wanting to check against. In this case that's redundant, we wouldn't actually need that, but it's good form to have it in there for when we have multiple things to check. We just reverse its direction. So you remember when the game was playing, the monster was going backward and forth. Every time he collided with a block, he turned around and went back the other way. So again, not a lot of code to make the monster work. So where all the real logic is in the player. So the player is moving around, and when he comes in contact with any of these objects, then he's going to handle that. So this will be the most complicated object. So let's have a look at the player, and you'll see it's still not that complicated really. So this first part's the same as all the others. We're just giving it an image, a size, setting the bounding rectangle for collision detection, and we've set the depth so that again we have that appropriate interaction. It's above the background, but it's behind those doorway bricks. Now in this one we want to also register for key events. So if somebody presses the keyboard, then we want to handle that. And again, this is for efficiency. We don't want to send keyboard events to every object. So the objects that want to handle them just have to register to handle them. And as with the monster, we're going to register collisions. If the player comes in contact with a block, a goal, or a monster, then we want to know about it. So we'll get notified of a collision if we collide with any of those things. And here we handle the collision. So we're handling the collision if it's a block, handling the collision if it's a goal, or handling it if it's the monster. So if it runs into a block, there's a built-in function in GameFrame called blocked. So I just say myself, that's this player, gets blocked. He can't go through that object. If it's the goal, then we set the room running to false. So we've finished the room will complete. And it'll be assumed that it was completed successfully because I haven't said anything to the contrary. I've just ended the room. And then finally, the monster. If I come in contact with the monster, then I'll update the room score. I'll take 1 off it, and I'll reset the player to where it was initially. So in this game, I've divided up the screen into 32 by 32 pixel blocks. And so I've created a grid essentially, if you can imagine a grid on the screen. And so the X position is 18 grids along, 18 32 times 32 pixels, and the Y coordinate is 15 down, so that's back to its original position. And lastly, to actually navigate the player, we registered for the key events, so then we implement this function key pressed, and we get the key, and we just check which type of key it is. If it's key left, key right, key up, or key down, then we'll move 4 pixels in the appropriate direction. And so that's it for the player. So we've defined all our objects, and you can see it's actually quite straightforward, very easy. Once you've got the documentation, you can just look up any of these things, and it's fairly simple to do. We've got an images folder, and that holds all our images, such as the background. So we've broken that up. I'll just close these off. And we also have the room. So you could have multiple rooms in a game. You could have multiple mazes, or you can actually change to a different type of game. Once you complete one level, you go to a different one. So if we have a look in this is how the room actually works. So again, it's not a lot of code. What have we got? 65 lines here. It might look a little bit scary to someone starting out, this structure here. But all you need to know is, once you've seen it once, you can just replicate it, copy and paste, and change bits. So this will all be given as example code. So what we're essentially doing here is we've got a level. So you can see it's our maze inherits from level. And again, that's just boilerplate code. But we set the background image by just simply calling set background image and loading an image. So an easy way to set up all the bricks, rather than manually go through and place every single object, what I've done here is just created an array of strings. And in the string, each item here is a label. If it's a B, then it's going to be a block. If it's a G, it'll be a goal. If it's a D, then it'll be a doorway. So you can see that was our doorway we went through. M is the monster, and P is the player. Of course, you can define these any way you like, but these are our 32 by 32 bricks. So you can just go through and set up the picture, and that's the way that the level will actually look. And then we've got this loop. Again, it'd be good to teach and to learn how the nested loops work, but if you don't know, you simply just copy this, copy paste as many of these as you want, and just replace the B, so the symbol, with whatever symbol you want, and create the object that applies to. So whenever we see a B, we're going to create a block, and we're going to put it in this location. So we're just iterating over this and putting the blocks or the objects in their appropriate space to begin with. And lastly, we wanted to add a banner so we could keep the number of lives information. So I can add that object and a banner, which we've defined in the objects up here. And what we've done is set the depth so that when we put the text on top of it, it's not obscured. And then lastly, we add the text, so there's a text object, and you can see we're just putting the word lives, and we're grabbing the current number of lives from the game. We set the depth so that it's on top. We've happened to set the color of it, and then we call update to actually create it and display it on the screen once we've added it. And then here's that function that we created to update the score. The reason why we did that is we didn't want to just change the score, we wanted to handle a couple of things at the same time. So we changed the number of lives, so we sent in -1, so lives will decrement by 1, and then we just do a quick check. If we've reached 0 lives, then the game's no longer running, but we also mention that we're quitting. So this is to say that the level's finished, but we failed the level, as opposed to just saying the level is finished and assuming that it was successfully finished. In the update score, after we've updated the score, then obviously we update the text and have it update on the screen. So that's it. That's the entire game. This is the most complicated part, only because this looks scary, but once you understand that, and you don't have to come up with it, you just copy and paste this and then change these values. If you want to get rid of a brick, you change it to an underscore. Underscore means put nothing there. And then just whatever the key is that you've used for here, then reflect it there. Otherwise, it's very basic, and it's all event driven. I don't have any linear progression or anything like that. I simply define what a room is, what's in the room, and I define those objects, and I define what happens when those objects collide or how they interact. And then that creates this game. Of course, the images you can change to any image you want, and you could change it so when the player goes left, you could change the image to a left-facing image. If it goes right, a right-facing image, up and down. You can just put that in where the key event that we had a look at. And that's basically it. So GameFrame makes it nice and easy. You only have to worry about the event, the logic of the events. You don't really have to worry about game loops or anything like that. That's all handled by the framework.